There is a saying that goes like this: where there is dust, there is a supernova, and James Webb Telescope truly reveals this particular interesting result here based on in-depth research and all these incredible visuals that is produced right here. And what we see is that we have two illustrations where there is a supernova event that led to the detection of gases that transforms into dust. And so what we are looking at here is, first we're going to see this particular location here, and two is the amount of dust that is created or maybe underestimated or overestimated. So let's dive into this particular result according to this article here that says that Webb locates dust reservoirs in two supernovae. And looking at this here, the location is around 22 million light years away from Earth, and this is here is in the location of the NGC 6946. This here is a spiral looking galaxy, and it has this incredible name that people call it the fireworks galaxy. Now inside this galaxy here, there are incredible visuals that shows events of supernovae, and this here shows also the detection of gases. And looking at this closely in terms of the overall look of the galaxy, this event most likely happened around the early universe, as this particular galaxy is focused on. And in addition to that, the type of supernovae that we are looking at here is a type 2 supernovae. Overall, there are two types of supernovae, but out of the two here, one of them is broken down into three parts, which is the first type of the supernovae. Now the second type of supernovae, which these particular supernovae are categorized as, is showing a characteristic that has its spectrum to contain hydrogen and helium. And further, according to astronomy.com, it says here that this type 2 supernovae is showing this particular characteristic where astronomers think that this results from the death of a star that is larger than 8 times our sun's mass. Now such star can fuse elements to iron, its core then heats up, then this bounces back to explode, and then spills heavy elements into space. Now the enormous explosion leaves behind a neutron star or possibly a black hole. Now this depends on the mass of the initial star. Type 2 supernovae are also called core collapse supernovae. Now the two supernovae in focus here, SN2004et, and the other one is SN2017eaw. And these two supernovae here, they are incredible in terms of what it reveals. It reveals a dust, and this also helps us to understand more about how this forged the early universe into how dust are created and how this can lead to building blocks of other parts of the universe, like for example the building of planets, also possibly building new stars. And this here is some of the essential elements for the next generation of the universe that we are looking forward to currently. And this here is going to be a direct evidence into the phenomenon that is showing our understanding of what amount of these particles are present in this particular location and other locations right here in terms of population. And so how is this also going to be different from how it was at the early universe? Maybe some of those dust particles that were already created were actually trapped due to obscurity in terms of their environment, but some others may have actually spilled out into outer space that we can't actually detect. And so this is where the detection technique comes into play here with the help of James Webb telescopes mid-infrared, because we can actually detect these particular dust particles in the infrared region rather than in the visible region. This result here will help us to fully understand more about a supernova that is really close to us, which is around 170,000 light years away from Earth. And this supernova here is called the Supernova 1987A, and this here is going to be essential for us to see how maybe that may contribute to deposit of dust that is in our solar system, specifically Earth, and maybe that may have impacted our own particular content of particles that are on our planet, like for example heavy elements or gases and many more things that may have transformed or cooled from gas forming to more of dust formation. Now you might be wondering the amount of dust that is created by such supernovae as shown right here. In this particular supernovae, it's incredible how James Webb is actually able to produce such number here, and according to the statement here, it says another particular intriguing result of this study isn't just the detection of dust, but the amount of dust detected at this early stage of the supernova life. And this SN2004et, the researchers found that more than 5,000 what Earth's masses of dust were actually detected here with the help of James Webb Telescope, which is really massive here. And so this here shows us that by calculating how much dust we are seeing from this particular region especially, it rivals the measurement of the one that is really close to us, and it is only a fraction of its age during the shock wave that is created by the supernova. This here, according to the results by James Webb Telescope, may be underestimated based on the amount that is stated, and this is going to be interesting to see how much of this dust actually survived, which is of course shown using this particular result, and how many of them didn't survive that particular shock wave that is generated here by the supernova. Now furthermore, another big question is how much of this dust that are not infrared detectable are actually present in this particular system, and this might be one of those things that are underrepresented in this following number that is stated right here. We know that we have this visible spectrum, and I'm sure of course Hubble has an image of this that we can see some, but how many of this dust can be seen with an infrared region or visible region, well, in this case? So it's really going to be interesting to see how they are able to get a much more accurate result that is definitely going to be more than what is stated right here in this article. So overall, I hope you found this really informative in terms of this incredible result by James Webb Telescope about supernova and how much dust is contained in this particular result that is shown here, the supernovae, and how this might impact our own understanding of the supernova that is closer to us, and how these dust particles that are created could make an impact in the overall cosmos in terms of some heavy metals that may be present in some planets, or how this might influence the formation of new stars and also planets, and something that looks like our own planet maybe, and maybe fostering life in as a result of this particular dust created. Overall, I hope you found this really informative. Hit a comment down below, let me hear your thoughts about this, but that way we can talk to you soon. Article has its link in the description box, check that out, and see you all on the next one. Stay smart as always and believe in yourselves.